Alright, in this video here, we're going to take a look at the practice final, and we're going to look at questions 88 through 109. I'll try to break it up into a couple of videos. For this first one, though, and actually for all these problems, we use the same chart. So I'm going to go ahead and put x1 in list 1 and x2 in list 2. Again, how we do that is if we go to Stat, Edit, we can go in and clear our list. Let's go ahead and clear list 1. And go over here, clear list 2. And I'll go ahead and clear list 3. Now, for first list, we're going to put the x1. So that's going to be 82, 65, 85, 89, 79, 89, and 90. Okay, we'll go over to list 2, and we'll put 84, 72, 85, 84, 77, 90, and 90. And for this first problem, we're actually only going to use list 1. But I wanted to go ahead and get list 2 in there. So let's go second quit, and let's start reading the question. So here it says, we have a list of x1 and x2. It says, is there evidence to suggest the mean of x1 is higher than 80 at a level of significance of 10% or 0.10? So the first thing we want to note is there are 7 numbers, so the degrees of freedom is 6. Okay. Now moving forward, it says, what is the mean of x1? So again, on the calculator, since we have the number in our list, we can do a one variable stat on list 1. So I'll go to stat, calculate, one variable stat, and by default it will do list 1. This one actually has list 3 in here, so I'm going to hit second stat and go down to list 1 and hit enter and calculate. So you can see the average, which is x bar, is 82.71 to 2 decimals. For the next question, it says, what is the sample standard deviation of x1? Well, if we look at our calculator, we actually have that calculated already. Remember, the sample standard deviation is SX, and here that's 8.807. So I did ask you to round it to 2 decimals, so that would be 8.81. Let's take a look at the next question. What is the test statistic T? So here, let me go ahead and get my, if I can type in. A little big, let's lower it a little bit. Okay, so here, remember, T is equal to, and we're going to do x bar minus mu divided by S divided by square root of n. Okay, and order of operations, if you're going to put this all in the calculator, you do have to use parentheses. So you will do the numerator first and then the denominator. So up here we can see, well, let's go back. Alright, so it says, is there evidence to suggest the mean of x1 is higher than 80? So that's going to be our null hypothesis. That's going to be mu equals 80. Okay, so take that into the next problem. So here, mu is equal to 80. Now, x bar is what we calculated, and that was 82.71. Oh, that's 7.1. Okay, remember that's in parentheses. Then we're going to divide that by sample standard deviation, which we calculated to be 8.81. Divided by the square root of n, which n was 7. Okay, and we go ahead and put this on our calculator. And again, if you're having trouble knowing how to put it in the calculator, I'll show you how to do it this time. I like to use the denominator first, so I'll do 8.81 divided by the square root, which is second square of 7. Okay, and I'll get that, and then I'm going to go ahead and put parentheses and do 82.71 minus 80, and then close parentheses. Uh-oh, I lost it. Okay, 82. No. All right. Let's clear that. 82.71 minus 80. Close the parentheses, and then I can divide that by the second answer. And that's going to give me 0.813. So to 2 decimal places, we get 0.81. So that's my test T statistic. Now, it says, what type of test are we conducting? So if we go back to our null hypothesis, it says x1 is higher than 80. So this is our null hypothesis here. So our alternate hypothesis is going to be that mu is greater than 80. And notice that the greater than is pointing to the right. So therefore, this means this is going to be a right tail test. Alright, so let's go back here, right tail test. Now it wants us to calculate the p-value. So we use our test statistic t. So if you recall, we do our normal curve, and our test statistic was 0.81. So I'll just write that in here. As a right tail test, so we're looking to the area to the right. And remember that that area is going to be the p-value. But remember, now we are in the t-test statistic, not the z, so we're going to have to use the degrees of freedom. So we're not going to use normal CDF, we're going to use t-CDF, right? So we have a lower bound, which is 0.81, and we'll need an upper bound, which we could use something like 1,000 would be fine. Okay? Or in this case, actually 100 is sufficient. That's what I used in my calculation, so I'll go ahead and keep it like that. As long as it's 4 standard deviations away from the mean. So I'll just type this in my calculator so you can see it. So the p-value is going to be second vars. And go down to option number 6 on my calculator, which is TCDF. That stands for cumulative density function. Our lower bound is going to be our 0.81, since we want to know the probability is greater than 0.81. And we use 100 for my upper bound. And then again, the added piece here is the degrees of freedom, which is n minus 1. So remember, n was 7, so my degrees of freedom is going to be 6. Okay, if I paste that in, I get 0.22. So that's my p-value, 0.22. That's the area, or that's the probability. I get a value greater than 0.81. So what does this all mean? Well, so our null hypothesis, or our p-value, was 0.22. Our alpha is 0.10. And notice that the p-value is greater than alpha. So this means that we are going to fail to reject the null hypothesis. So again, thinking in terms of the claim, remember we had the null hypothesis that mu was equal to 80. And you had the alternate hypothesis that mu was greater than 80. So when we fail to reject the null hypothesis, that means we're kind of saying there's evidence to support that it's true. Therefore, we would not support the claim that it was greater than 80 at a level of 0.10.